Aloha, Richard Halverson here. This is ITS128, and today is October 20th. It's exactly 2 weeks before election, or before the rest of the country votes. Fortunately, in Hawaii, we have all mail-in ballots, so I've already voted. Hope you have too. Anyway, so let me share my screen. And we are, let's see if I can figure this out. No, there we are. We're in this week 9, and I have, let's see, I said last week that we're going to finish up chapter 5 today, and it's good because a lot of you have been contacting me because you're having trouble with chapter 5. And so, you know, I have to sort of, reflect and look inward and try to figure out what I can do to try to explain these concepts better. And I have to try to go back to the way it was before I could program. And one thing we used to do a lot, I mentioned this in the old days, is we would desk check our code before we would execute it, because executing your code would generally take 20 minutes. You submit your job and you wait 20 minutes and your output is there, and then you were able to take your code, and if you had a little error in there, you had to fix it by probably punching a new card and then submitting it and waiting another 20 minutes. So I'm gonna do everything today. I'm gonna desk check the code before we actually execute it the first time. So now the first thing is a couple of you actually have asked me about these break and continue statements. And break and continue are not found very often in other languages, and people don't generally use them that much. They sort of go against the philosophy of structured programming, where each block has one entry point and one exit point. I'm going to start this program here in 5.10. This is actually a little bit complex, so I think I might come back to that. Let's go down here and start with, let's see, what's this? Given the following while loop, what is the value of z assigned? Z is assigned with for the given value variables a, b, and c. Okay, so let's just see what this looks like. And I've opened up my little whiteboard here, and so we have a variable called mult. So I'm gonna wait a second, I gotta do this. We have a variable called mult, and we have a variable called a, and we have a variable called c. What are we supposed to? Oh, we have a variable called a, and we have a variable called c, and we have a variable called z. Okay, these are our 4 variables. Now let's step through this program. First of all, mult is set equal to 0. Let me open this up here in case anybody wants to. Where is my chat? Okay, good. I got that there now. Okay, so we start out, mult is set equal to 0. So this is going to be, I'm going to do this. I'm going to have, and these will be like different values for the variables here. I don't know how many we're going to use, but okay, so we've got the variable mult, we've got the variable A, we got the variable C, and we got the variable Z. I'm going to change colors here now. Okay, so we start out with mult equals 0. So mult is equal to 0. And then we have no, we start out with A equals 1. A equals 1. It's a 1. B, oh, we forgot B. I'm going to do this. I'm going to make this look nice. Get this rid of this. Rid of this here. And I'm going to go like this. And like this. I'm going to go, there's a B and a C and a Z. Okay, so A is 1. B is 1. And C is 20. Okay, so that's how we start. Okay, so the first thing we do is we set mult equal to 0. I just did that up here. And then is A less than 10? Yes, A is 1, so A is less than 10. So that means we go into the loop, which is this is the loop right here. And this next thing we do is mult equals B times A. Well, B is 1, A is 1, so mult is now equal to 1. Because 1 times 1 is 1. Okay, now, is mult greater than C? Mult is 1, C is 2. No, mult is not greater than C. So we do not take the then part of the if. We skip over that so we don't break. And then we go, and then this is executed. A equals A plus 1. So now A is equal to 2. And we go back up to the top here. Is A less than 10? No. Is A less than 10? Yes, it's less than 10. So we do the body of the while loop, and then which is this. Mult equals B times A. Well, A is 2, B is still 1. So mult equals 2 times 1 is 2. Okay, is mult greater than C? No, mult is not greater than C. Mult is less than C. Mult is 2, and C is 20. So we skip over the break. We don't do the break, and then we execute this statement here, which is A equals A plus 1. So now A is equal to 3. And then we go back up to the top. Is A less than 10? Yes, it is less than 10. It's 3. Set mult equal B times A. So B is 1. A is 3, so mult is equal to 3. It's taking a while here. Is mult greater than C? No, it's not, because C is... Wait, how did C get to be 20? C is 0. Why did I put 20? Maybe I saw this 20. Sorry, it should be this 20. Let's I hate this. All right, let's start over again with this thing. I think this is faster. Get rid of this. 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 Hey, by the way, if you ever see me make a stupid mistake like this, just let me know. Yeah, try to blame you for my mistake. All right, so multis, it's 1. Oops. A is 1, B is 1, C is 0. Okay, so let's multi set equal to 0. Is A less than 10? Yes, A is equal to 1, so it's less than 10. Mult equals B times A, so B is 1, A is 1. 1 times 1 is 1, so mult now equals 1. Is mult greater than C? Yes, mult is 1 and C is 0. So mult is greater than C. So then we break. So what does break do? Break breaks us out of the while loop, and it executes the first statement after the while loop. So it breaks out to the first statement after the while loop. Okay, so that's Z equals A. So what is A? A is 1, so Z is 1. So, so what are we supposed to put here? What is the value? What is the value variable z is assigned when with for the given values of a, b, and c? Well, z is equal to 1, it looks like. So let's put a 1 there and see what we get. Oh, that's nice. Okay. Let's try this. Let's go ahead and try. No, let's. Okay. So that's an example of desk checking, where we create a little table like this, and so that's how we're going to do this. Okay. I'm going to skip over this because it's complicated. Let's go down and try this challenge activity here. Somebody asked about the challenge activity specifically. So, all right, for this, let's start by tracing through what is already here. Okay. So I'm gonna erase this, clear canvas, and I'm gonna have a variable called stop, and a variable called result. And a variable called n, and result, stop, and result. Okay, I got my 3 variables here. Now, little table here. Hope this is enough. And we'll see these as they change. Okay, the first we execute, we set stop equal to the input. Well, the input is 5. We change that character 5 to the value, the integer value 5, and put that in stop. So what goes in here is 5. And then result is equal to 0. So let's put a 0 in here. Now, n in the range of 10. So n starts out at 0 and could possibly go all the way up to 9 unless this break is executed. So n is going to start, this goes from 0 to 9, but it starts out at 0. So let's start it out with 0. And then we go into the body of the for loop and result. So we take result and first we multiply n by 4, and then we add it. We add that to result. So n is 0. 0 times 4 is 0, and we add that to result. So result stays 0. I'm just going to put the 0 here because that's what it. So 0 plus 0 is 0 because n is 0. Now, is the result greater than stop? What's stop? Stop is 5. Result is 0. So no, it's not greater than stop. So we do not break, and we print the n. So down here, I'm gonna just do n is 0. So I'm gonna print. Let me do this. Print. I'll do this. Print. And so the first thing we print is 0, because we print n, and n is 0. Okay, then we go back up to the body of the loop, and now n is equal to 1. So I'm going to put a 1 here, and then I'm going to take n times 4, and 1 times 4. 1 times 4 is 4, and I'm going to add that to result. So now result becomes 4. And is result greater than stop? No, stop is 5. Result is 4, so result is not greater than 5. So we do not do the break. We don't do that. Instead, okay, and then we print this. So the next thing we're going to print is what n is, and n is 1. So that's why the 1 gets printed. And then we go back up to here again, and we take the next iteration. And so that would be n equals 2. So let's put a 2 here. And then we take 2 times 4 equals 8. And so we add 8 to result. What's result? It's 4. 4 plus 8 is 12. Is 12 greater than stop? Yes, it is. Stop is only 5. 12 is greater than 5. So we take the break. Okay, we take the break and we go outside the for loop. So we jump all the way to the outside the for loop. This is the for loop, and this is the next statement after the for loop. So it's that. So we print out result. What's result? Result is 12. And then we're done. And we see here at 0, 1, 12. Okay, fantastic. Let's do the next one. Oh, I got to start. Okay, here we go. We got start result, same thing, except for input is 10 now. Okay, so let me just erase-o-matic here. Let me erase this. Why doesn't this erase? I'm just going to clear the canvas. What the heck? All right, let's start. Let's do, there's a stop. And there's a result. And there is a N. Same stuff, I guess. Result, stop, okay. Okay, so first of all, we read the input, and that gets stored in the stop, into the variable stop. So the input is 10. So stop is going to be, I don't know how many I'll need. So stop is going to be, and then I'm going to print down here. So stop is 10, put a 10 there. And then result is 0, put a 0 here. Close those zeros. And see what happens. Close them like that. Yeah. Result is n times 2. Oh, n goes from, again, it goes from 0 to 9. So it's going to start out at 0. Okay, now result is equal to, take n, which is 0, multiply it by 2. 0 times 2 is 0. And add that to result. Well, that's 0. So we add 0 to result, and we just get 0. So result is still 0. Is result greater than stop? Well, stop is 10. And so it's not greater than stop, so we do not break. Instead, we print n. So n is 0. So we're going to print 0. That's the first one. And then we go back up to the for loop and set n equal to 1. Now n is the next one, which is 1. And then we take n, which is 1, times 2. 1 times 2 is 2. And we add 2 to result. So 0 plus 2 is 2. And then is result greater than stop? That's funny. I have this habit of donating to political campaigns. Okay, so every morning when I wake up, my text message thing is full of people of campaigns asking me for money, and they share the phone numbers. Okay, so it's like I get these they're all of the party of my interest, but they share these things. And I just got another one here. I don't even know who this person is. I don't even know who that person is. Anyway, somebody from Arkansas or something. Kind of funny, but I don't mind ignoring text messages unless they're from you. All right, let's keep moving here. So result is equal to 2. Is result greater than stop? No, stop is 10. 2 is not greater than 10, so we do not take the break. Instead, we print n. What's n? N is 1, so it's going to print the 1. And then we go back up to the for loop, and now n is 2 because it was 1. Now it goes to 2. So this is 2. And we take 2 times 2 is 4. We add 4 to result. So 4 plus 2 is 6. Is 6 greater than 10? Is 6 greater than 10? No. So we don't take the break. Instead, we just print n. And so printing n, so we print the 2. And we go back up to here. N is equal to, now n is equal to, we add 1, n is equal to 3. And then we take n, which is 3 times 2 is 6. 3 times 2 is 6, so we add 6 onto result. 6 plus 6 is 12. Is result greater than stop? Is 12 greater than 10? Yes, it is. So we do take the break, and we jump outside the for loop, which would be this thing, because it's the next one down. And then we print our result, and then we're done. So what's result? Result is 12. So we print the 12, and then we're done. So let's see if that is correct. 0, enter. 1, enter. 2, enter. 12, enter. Check. Yeah. Great. Okay, fantastic. Let's do the next one. All right, same. And now we're doing a continue. Continues goes back up to the top without finishing the loop. When we come across a continue, it goes back up to the top of the innermost loop, skipping everything else that's remaining in the loop. So let's start with this. I wonder why this doesn't work. Doesn't erase the circular fingers. That's weird. All right, I guess I have to. This. And then this should work. Okay, let's start over again. Result is equal to 0. So let's put a 0 in result. And we're going to loop. N goes from 0 to 7. No, not 8, goes from 0 to 7. So N starts out at 0. I'm going to have trouble erasing that now, I guess. What's stop? There's no stop. There's just N, result, and that's it. Okay, so I guess we're not going to use stop this time. Okay, so result is equal to N plus 2. So we aren't adding 2 to N and then adding that to result. It's not plus equals. It's just plain old equals. So N is 0, plus 2 is 2, and that's what result is equal to. So now result is equal to 2. And if result mod 2 is not equal to 0, then do this and do this. Otherwise, if this is false, then we skip out and just do this. So result is 2. 2 mod 2 is going to be 0. 2, when you take 2 and divide it by 2, the remainder is 0. So is 0 not equal to 0? No, this is false. So this is false. So we don't do this then part. We skip out and we just do the next statement after the if, which is this. And so, excuse me, what we're going to do is we're going to print out result. What's result? It's 0, 0, and then a space. Okay. I'll do that for a space because we've got this thing. Okay. And then we go back up and let's do the next loop. And so N now is equal to 1. Result is equal to N plus 2. N is 1 plus 2 is 3. So now result is equal to 3. 1 plus 2 is 3. So now result is equal to 3. If result mod 2 is not equal to 0, then we do this part. Well, what is result mod 2? Result is 3 mod 2 is 3 divided by 2 equals 1 with remainder of 1. So this is what the mod is. This is the mod. That's the result of the mod. This is equal to 1. And so is that not equal to 0? That it's true. It's true that 1 is not equal to 0. So then we do this part. And we print out a hyphen. I guess we print out a hyphen. And we do another space. And then we do this continue. And what continue does is continue goes back up here, and it takes the next value for n. So n is now equal to 2. Are we going to go all the way to 7? I guess we are. So now n is 2. Result is now it's 2 plus 2 is 4. So result is going to equal to 4. 4 mod 2 is 0 because 4 divided by 2 is 2 with a remainder of 0. So result 4 mod 2 is 0. So this is false. So we skip this and we jump right to this. And so we do result. Result is 4. So it's going to be 4 space. And then we go back up here again and we do n is now equal to 3. And so 3 plus 2 is 5. So result is equal to 5. And 5 mod 2 is 5 divided by 2 is 2 with a remainder of 1. I'm going to have to erase this here because I'm going to be going over there. 5 mod 2 is 1. So this is true. It's true that 1 is not equal to 0. So then we print this hyphen space thing. Hyphen space. I'm going to do a little notchy thing for a space. Okay. Yeah, because 5 mod 2 is not equal to 0. So we did that. Now we continue, which means we skip up and take the next n. What's the next n? Well, it's 4. Result equals 4 plus 2 is 6. So now result is equal to 6. I'm not going to have enough room here, am I? Let me just go like this. Can I go like this? Yeah, I guess I can do that. So now n is equal to 6. No, result is equal to 6 because 4 plus 2 is 6. Result is equal to 6. 6 mod 2 is 0. 6 divided by 2 is 3 with a remainder of 0. So that's equal. So the 6 mod 2 is equal to 0. So this is false. So then we skip this part and we go down to here and we print out result. What's result? Result is 6. So we're going to do a 6 followed by a little space. And we go back up to here and we take the next value of n, which is 5. And 5 plus 2 is 7. So now result is equal to 7. 7 mod, so you can see the pattern here. I don't want to talk politics. So so 7 mod 2 is 1, because 7 divided by 2 is 3, the remainder of 1. So this is true. So then we print this hyphen thing. So let's do the hyphen thing. Space. And then we do this. So we go back up here and continue. We skip the rest of the for loop and go back up here. Now n is equal to 6. And 6 plus 2 is 8. So result is equal to 8. Result is equal to 8. Because 6 plus 2 is 8. And 8 mod 2 is equal to 0. It's this, so this is false. So then we go down to here and we print the print result. So it's going to be 8. A little spacey thing. And then we go back up here and n is, we increment n by 1. It hasn't hit the top yet. It's almost there though. So n is now going to equal 7. N is equal to 7. 7 plus 2 is 9. 9 mod 2 is equal to 1. And so we do this part. And so it's going to be a hyphen thing. And then we continue. So we go back up here and take the next value from n. And n, we increment n by 1, and it becomes 8. And 8 is too big. 8 is beyond the range, because with this here, range is going to be 0 through 7. So we're done. So we're done with the for loop. So we go down here and we print done. So it's going to be that. I guess we're going to print done now. Done. O-N-E with a little spacey thing. No spacey thing. Okay, so let's see if that's the right answer. 0. Wait. Oh yeah, because okay, let's see if that's the right answer. 0 space hyphen space 4 space hyphen space 6 space hyphen space 8 space hyphen space done. Enter. Because this is going to cause an enter. Yes, I'm going to do a 5, 21, 22, and 23 after this. All right, so is this the right answer? Check. Uh-oh. Uh-oh. I had the wrong answer. The first one is supposed to be 2. Okay, now let's see what I did wrong. We start out with 0. Result is 0. N is going to start out at 0. And result is n plus 2, which is 2. 2 mod 2 is 0. So we're going to skip out this and we print result. This should have been a 2. I wonder how many people saw that. All right, so I'm going to get rid of this thing. Trash it. Should be 2. Oops, 2. All right, so my desk checking wasn't right, but anyway, you get the idea with desk checking. Let's just quickly do this. Let's take a look at the third one, so I want to make sure we get them right. Okay, so I need to. It's going to make me do 2 again. Okay, well let's do 2 again, and then we can. It's 3:50. I want to start on the problems. So we have a result. We have an n. We have a result. That's it. Okay, so let's. I'm gonna start over with this. we have a result. We have a result. And we have an N. And we have a, that's it. Okay. And maybe I'll do it, maybe instead I'm going to do it this way. I'm going to try it this way. A result and N. N. Okay. So we start out with result equals 0. And N is going to be 0. I'm using blue. That's okay. Result is N minus 2. So N is 0. This is a bad N. So result is now N minus 2. So that is equal to, I guess I can put this over here. I can do this. Result is N minus 2. So now result is minus 2, yeah? Yeah, minus 2. Result result mod 2 equal to 0? Minus 2 mod 2 is minus 2 divided by 2 is minus 1 with a remainder of 0. So this is false. And so if that's false, then we skip down here and we just do result. Yes, result. So we print result. I'm gonna, I guess I'll do that down here because it's gonna be a cross like this. So we print result is minus 2 with a space. And then we go back up here and N is gonna be, N is gonna be 1. And N minus 2 is minus 1 minus 2 is minus 1. So result is going to be minus 1. And minus 1 mod 2 is not 0. Minus 1 mod 2 is 1. So this happens. So this gets executed. And so what happens is a minus a hyphen gets printed along with the space. And we go back up here, and N is going to be N is now 2, and this is going to be 2 minus 2 is 0. Result is 0, and is 0 mod 2 not equal to 0? It is. This is false. 0 mod 2 is equal to 0, so that's false. So it prints the result. The result is 0. And then we go back up here, and this becomes 3. Oops, wrong color. And 3 minus 2 is 1. So this becomes a 1. And this is going to be false. No, it's true. 1 mod 2 is not 0. So we print a hyphen. Oh, there should be a space there. Hyphen space. And we continue, and N becomes 3. 4, I mean. And 4 minus 2 is 2. This becomes 2. And 2 mod 2 is equal to 0. So it's skipped and result is printed 2. And we come back around again. And N is now equal to 5. And 5 minus 2 is 3. and 3 mod 2 is not equal to 0. So so this is true. So print the hyphen with a space. And we continue, and we're at the end. So now we print done. Done. And is that right? I hope this is right. -2 hyphen 0 hyphen 2 hyphen done. Let's see if that's right. Yeah, that's right. Okay. Anyway, that's a good desk checking thing. You can go. You should be able to finish those up now. So let's look at the ones I was going to cover for today. And those are those would be 521. Okay, this one. Okay, let's start with this one. Okay, in this one, we're supposed to find this. We're supposed to go through this list and find the smallest and the largest. Now, there's a couple of ways that we can do this. Okay, first of all, the program reads in a list of integers, and then outputs the smallest and largest. So it reads in all these integers, and as long as what it is reading in is greater than 0, then it's going to read the next one until it finally reads one that is not greater than 0, and then it's going to stop. Okay, so these integers are going to be connected to are going to be considered part of the list as long as they're greater than 0. So the list is really 10, 5, 3, 21, and 2. And then as it reads it in, it's going to, there's a couple of ways of doing this. I'm going to do it the way where we just keep track of the largest and the smallest as we read it in. So, so first of all, we want to, I guess we want to loop reading in numbers. Okay, so I'm going to start by, I'm going to read in the first number, and I'm going to call it user, I'll just call it user input, equals integer of input. Okay, so I have a variable called user input. And it's going to read it in, and then I'm going to initialize. I'm going to have a variable. What's going on here? I'm going to have a variable which I'm going to keep track of the minimum, the smallest one, and the largest one. So I'm going to have another variable called smallest, and another one called largest. Okay, now I've got to initialize these as something to start out, and I'm just going to initialize them both as this first number. So the first number is 10. So this starts out equaling 10. Okay, and so I'm going to set smallest equal to user input, and I'm going to set largest equal to user input. Okay, so smallest is going to equal to 10, and largest is going to equal to 10. Okay, then I'm going to have a loop. I'm going to have a while loop because I need to check to see if the input is negative. If the input's negative, I'm done. So I have to have a while loop here, which goes while user input is greater than or equal to 0, then do the loop. Otherwise, I'm done. So, I better do this. Can I assume that there's going to be at least one? Oh, assume the list of integers will have at least 2 values. Great. So I can do this. So I'm going to put these back up here. And I guess I can leave this the way it is. I'm just gonna be lazy here, and I'm gonna do another user input equals int. This is not very good code, but as long as it works. So I'm reading another input. And so now the next input is going to be whatever this is. What is this? 5, 3. I'm going to write it here. 10, 5, 3, 21, 2, minus 6. Okay, so the next input is 5. And so is 5 greater than 0? Yes, it is. So then I can do largest has a value and smallest has a value. So I have to check if this new input is less than the smallest, less than what I have for smallest. And if it is, I've got to set smallest equal to this value. Okay, so if user input is less than smallest, then if it's true, then I want to set smallest equal to this new user input. Smallest is equal to user input. Otherwise, okay, so it's not going to, the user input, it's either going to be smaller than the smallest or not. And if it's not, we can check to see if it's larger than the largest. But it's not going to be both. Okay, it can't be both. So I'm going to do else, elif user input is greater than the largest. Then if that's true, I want to set the largest, then I have a new value for largest. So I'm going to do largest equals user input. And if it's neither of those, then we just read it in and we don't do anything to it. But it's time. And now before we go back up to the top of this while loop here, I got to add another. I got to add this again. Right here, and that completes the body of my while loop. So this thing is going to keep on executing until it gets a user input that's less than 0. And when the user input is done, when we do finally get a user input that's less than 0, then we jump down here. We skip over the body of the while loop, and then we can print smallest and largest. Okay, so I'm gonna desk check this. It's 4:05. I'm gonna do this differently. So we've got user input. And we've got smallest and largest. And our inputs are, oh, that's pretty cool. I don't want to do that. I'm going to just put here 10. So the user inputs coming in are 10, 5, 3, 21, 2, minus 6. And if we desk check this now, if we desk check our code, we start out with user input equal 10. The smallest is going to be 10, and the largest is going to be 10. Okay. And then I got to read in another user input, and that's going to be this one, the 5. So right here it's 5. User input's 5. And then is 5 greater than or equal to 0? Yes, it is. So let's check this one. Is 5 less than smallest? Is 5 less than smallest? Yes, it is. So we execute this. We set smallest equal to 5. And then we can skip out and we go to here and we read the next one. And so now we're here. And we go back up here. Is user input greater than 0? Yes, it is. It's fine. Is user input less than smallest? Is 3 less than 5? Yes, it is. So we're going to execute this one again. And so now user smallest is equal to 3. And we skip the else. And we read in another one. And now we got 21. We're at 21. Go up here. Is 21 greater than 0? Yes, it's greater than 0. And so we go down here. Is user input less than smallest? Is 21 less than 3? Is 21 less than 3? No, it's not. So we go to the else. Is 21 greater than the largest? Yes, it is. 21 is greater than 10. So now 10 is equal to, so then we execute, we have a new largest. And so we set largest equal to 21. And then we read another input and it's 2. So we go back up here. Is 2 greater than 0? Yes, it is. Is 2 less than the smallest? Well, the smallest is 3, and we're reading in a 2. Yes, it is. 2 is less than 3. So then we execute the smallest part, and that's going to be a 2. Now smallest is equal to 2. We read in another user input. It's 6. Is 6 greater than or equal to 0? No, it's not. So then we go down here, and we print out the smallest, which is a 2, and the largest is 21. And so let's see what happens when we submit this. And I got the right answer, I think. Yes. Okay, very excellent. So that one works. So someone just asked the question. Oh, you can see what the question is. Okay, good. So can we just use one? Yeah, I'm sure we can. How do we do this? Yeah. I think we can just get rid of this, because the list is going to have at least 2. So we will certainly be reading another one. Yeah, I think we can get rid of that. Let's see. Yeah, we can. That's it. Yeah, very good. See, you're getting it. Very good. Okay, let's. We're not got 20 minutes here. Let's jam through the next 2. All right, output values in a list below a user-defined amount. Okay, so for this one, we read in a bunch of numbers for a list. So the way it works is the first thing we read in is the number of integers in the list. So we're going to read in 5 in it. So this, we put 5 there, which means we're going to read the next 5 integers are part of the list. So 1, 2, 3, 4, 5. And then the last number we read in is a threshold number. And what we're supposed to do is once we read that threshold number, we got to go back through the list that we read in and figure out all of the integers that are less than or equal to the threshold. Output all the integers less than or equal to the threshold, that last threshold value. So that means we actually have to store these in a list because we don't know what the threshold is until we have to actually read in the whole list. So this time we need to actually create a list. So to do that, let's start with and I'm going to use smaller variables here. I'm going to say, I'm going to call my list UVS, no, user value list. I'm going to call it that. How's that? Is equal to a list. So I've defined UV list as a list. And now I got to read in the how many. So the first thing I read in is how many elements there's going to be in the list. So I'm going to say n, I'm just going to call it n, equals, integer of input. Okay, so that's going to read in how many n. So in this case up here, it's going to be the 5, yeah. Okay, so now I got to read in the whole list. So let's do that, and I can just do 4. Let's use a for loop 4, and I'm going to use a what's a good p index I for index in the range of n. Okay, so it's going to go from 0 to n minus 1, and that's 0 to n minus 1 is n numbers. So while that is, let's append UV list append int input. I can do it this way, or I can do something. How about user input equals this, and I'm going to append user input onto the list. Okay, great. When I'm done with that, I'm supposed to read in a threshold. So T for threshold equals int input. Okay, so now I got my threshold. Now I got to loop through the list again, and I'm going to print out all of the values that are less than or equal to the threshold. Is that right? Output all integers less than or equal to the threshold value. Okay, so so I can just do this for this thing again. I'm just going to do this dang thing again. Put that there. And for that, for the range, if UV list of index, that's how we access that particular one. It's going to start at 0, 1, 2, 3, 4. If that is less than or equal to the threshold, then print. How do I? Oh, I can just, okay. So I just print UV list. So basically, 16. Okay. So basically, I'll speed this up a little bit here. We've got UV list. And we read an N, which is 5, and we do index. So you can see that this loads up UV list. So UV list is going to be, in this example, 5, 50, no, not 5, 50, 50, and I'm going to not, 50, 60, 140, 200, 75. So those are the 5 values, 1, 2, 3, 4, 5. And our threshold is 100. T equals 100. Okay. And so here, this looping from 0 to the index goes from 0 to 4. So when index is 0, 1, 2, 3, 4, there's 5 of them in there. So when the index is that, then we're pointing to this one. Is this one less than the threshold? Yes, it is. So we print. I'm going to do print. Is this less than the threshold? Yes, it is less than, because I'm doing this test right here. Yes, 50 is less than 100, so we print out the 50. And then we go back around, and index is now 1. So now we're pointing to this one. That's index 1. Is 60 less than 100? Yes, it is. And then we go back around, and this is this one. Is 140 less than 100? No, it's not. So we skip it. See, this is false. 140 is not less than 100, so we do not print. We go back up to here again, and we look at this one. We're on the number 3 now. This is number 3. 0, 1, 2, 3. Is 200 less than 100? No, it's not. So we don't print that. And so this is false. Go back around again. And the last one, index 4, is this one. Is 75 less than 100? Yes, it is. So we print the 75. And then we're done. So let's see if this works. Lo and behold. All right. So let's do the last one here. Try to do the last one. And I'm going to try not to do the whole thing for you this time. Okay. Leave a little bit for you to work on. All right, 23. Adjust the values in the list by normalizing. Okay, this is kind of a dumb problem, because this doesn't have much to do with what we're going to do. But basically, what normalizing is we got a bunch of numbers coming in, and we want to normalize them between 0 and 1. I don't know. But what we have to do is to write a program that first gets a list of integers from input. Then we go through each one of them, and we figure out what the smallest one is. The input begins with an integer indicating the number of integers that follow, just like the last one. We get, so 5, we're going to read in five numbers, 1, 2, 3, 4, 5. And then what we want to do is we want to figure out what the smallest one is. It looks like it's 10. And then we want to go through, start back up at the top of the list again, and we want to subtract 10 from each one of these. So this is going to turn into 10. 30 minus 10 is 20. This is going to be 20. This is going to be 40. This this is going to be 0, this is going to be 60, and this is going to be 55. See, so 20, 40, 0, 60, 55. And basically the idea here is we are making it so the smallest one is 0, and all the rest of them are adjusted accordingly. Okay, so let's start this again, and I'm gonna so I'm gonna start out by reading in a list, and I'm gonna call the list list. Can I call it list? Is that a reserved word? How about if I call it my list? Okay, so I'm gonna define a list called my list. My list equals a list. And then I got to read in how many integers are going to be in the list. So I can, let's call it n again, is equal to, I'm going to input an integer. So n is the number that I'm going to read in. Now let's do a for loop to read them all in. For index I in the range of n, okay, read in the integer and store it into the list. So let's read the integer. User input is equal to an integer input. So I read in a variable called UI. I read in an integer, and that's going to be stored in a variable called UI. And then I'm going to store it into the list. So my, and now I use the append function. My list append whatever UI is. So I have a my list. I have a my list. It is a list. And I read in n, so n is equals 5. So n goes from 0, 1, 2, 3, 4. And my list of 0 is equal to something. It's going to be equal to 30. And my list of 1 is going to equal to 50. And my list of 2 is going to equal to 10. And my list of 3 is going to equal to 70. And my list of 4 is going to equal to 65. Okay, so now so this is going to be, this reads in the 30 and the 50 and the 10 and the 70 and the 65, and each time it gets appended onto my list. Okay, so when this loop is done, my list is all filled up. Okay, now how do we figure out what the smallest element of that list is? Well, there's a couple of ways we can do it. One way is, as we're reading it in, we can keep track of the smallest one. Remember, we did that before in 2 problems ago. How is UI defined? Oh, right here. We read in the input. UI. This is UI. We read in the 30. We read in the 50. We read in the 10. We read in the 70. Then we read in the 65. Does that make sense? So the first time this executes, it reads in. See, okay, so let's count the inputs. Here's 1 input, and that's 5. And then we're going to loop 5 times. So the second one is going to be second. So this is the first one, and then the second, third, fourth, fifth, and sixth. Yeah. So it's first one, second one, third one, fourth one, fifth one, sixth one. Okay. So that's that. And so we could keep track of the smallest one here like this. We could say it's the initialization that's the hard thing. So let's see. Is there anything that we okay, so we could figure out some sort of looping thing where we initialize something as maybe initialize it as a really big number, and as we loop through, we keep track of the smallest one. Well, we can do that like this. First one. We can do something like this. Init equals false. If init if not init, then smallest equals UI, and then set init equals true. Otherwise, if UI is less than smallest, then smallest equals UI. Okay, so that would, when that executes, it would arrive at the smallest one. I mean, when this thing is done executing, this variable will keep track of the smallest one. We could do, yeah, we could do this actually. No, we can't do that because I don't think you've learned that yet. Okay. All right, so that's one way to do it. The other way to do it is to use the min function, Python min function. And what that is if we have a list, iterable list, the min function will give us the smallest one. So here we have this is in a tuple. This is going to give us x is equal to the smallest one, which in this case is 1. How about all right. So min is another way to do it. So instead of this, you can do it either way. We can say smallest equals min of my list. I think that'll work. Okay, then we just have to go through the loop again, and we do we go through this range. For I in range of however many there are on the list, and we know that it's not going to change, so it's just going to be that, and we can just say, what do we print them out or something? Print print my list. Well, PV, print value, equals my list of I minus smallest, and then print that. Okay, so it's going to be something like that. It's 430. So if you do have a smallest equals min of my list, then you loop through this whole thing again. N equals 0, 1, 2, 3, 4, and my list of 0 minus smallest, and that's what you print. You print that. And so you go through each one of them, subtracting whatever the smallest one is. It's 10. So it's going to print 30 minus 10, 50 minus 10, 10 minus 10, 70 minus 10, 65 minus 10. Okay, so I don't want to actually run this because then I'm completely for sure telling you exactly how to do it. So, type that in, and that should get you the right answer. All right, so that is the end of chapter 5. Now, you can, I'm going to leave it up to you to tell me if you still want me to cover a little bit more in chapter 5. In fact, I've gotten some emails from some of you, chapter 5 it's probably the hardest thing. Loops are probably the hardest thing, and when you throw in continue and break, that even makes it more complicated. Turns out you can do everything without continue and break. It also turns out that you can do everything in just a while, but you have to have some sort of loop, conditional loop construct that where you're able to test each iteration whether or not you should do another iteration or not. So feel very comfortable to email me if you still would like a little bit more help with this chapter. And I'm going to help somebody tomorrow. And if you email me by tomorrow, then I can email you when I'm going to meet with this person. And I'm just going to go through chapter 5 again, covering items briefly. I'll probably go through the challenge exercises and do this desk checking with, putting the variables up and stepping through it. And after a while, you should be able to kind of think of them in your head. And the drawing that I do, you should be able just to step through slowly, sort of keeping track of all of the variables. You keep track of what's in here, and you keep track of what's in the list, each element of the list. You're going to make positions for each element in the list, and you have little spaces for each of the variables, and you just kind of step through it slowly. And then after a while, when you get used to that, you won't need to draw. You don't need to write them down anymore. You should just be able to sort of step through it in your head, maybe taking some notes to keep track. And then after a while, it should be, and it's kind of a trick. The trick is to see a problem and then try to formulate in your head sort of an overall approach. And you have in your toolbox, looping, and you have this if thing. And from that's really all you need to be able to put it all together into something that works. And then as long as you know what your output is supposed to look like, and what's great about these problems is it always gives you an example to test. it becomes easier and easier to be able to step through in your head, desk check in your head. What's great about programming today is you can just run it. If it works, you know, if you know what your output's supposed to look like, you run it and you see if that's the right output. And if it's the right output, it's probably the right answer. You know, you got to be careful because sometimes there's some tricky stuff off by one. If you were to have a loop and you were off by one, let's say your loop didn't go through all of the elements in the list. Let's say it skipped the last one or something. Or maybe your loop was such that it goes over the last one. You need to use test data to make sure you test what are called the boundary conditions. We'll talk more about that later. But anyways.
Thank you, Mr. Halverson.
Okay, so are there any more questions? No more questions? I will see you on Thursday.
Thank you very much.
Thanks for watching. See ya.